Have you ever finished a low-calorie meal, yet found yourself hungry again an hour later? That simple experience raises a surprising question. What if your body isn't counting calories at all? Calories measure energy on a food label, but according to the source material, your body responds mainly to biological satiety signals, especially protein and fat. When those signals are too weak, hunger may continue even after you've eaten enough calories. This helps explain why many people struggle with constant cravings despite carefully limiting their food. The real challenge may not be eating less, but giving your body the nutrients it is actually looking for. And that leads to the next question. How do these natural signals influence hunger, fullness, and long-term weight control? If protein plays such an important role in fullness, why does your body care so much about it? The answer lies far beyond weight loss. Protein supplies the building blocks needed to produce hormones, repair worn tissues, maintain muscles, and replace aging cells every day. Because these jobs never stop, your brain continuously monitors whether enough protein is coming in. When intake falls short, hunger signals may remain active, encouraging you to keep eating until that need is better satisfied. This is why some meals leave you feeling full for hours, while others seem to disappear almost immediately. Research in humans suggests that higher protein meals may increase satiety for many people, although the response varies with age, activity level, and overall diet. Imagine protein as the construction material for an endless renovation project. If deliveries slow down, the foreman keeps ordering more supplies. Your appetite may work in a similar way. But protein is only one part of the equation. The second satiety signal may be just as important, and its role often surprises people. But protein is only half of the story. The second satiety signal comes from a nutrient that has often been misunderstood: natural dietary fat. Instead of making you hungry, fat may help you stay satisfied by slowing the rate at which food leaves the stomach. This gives your digestive system more time to communicate with the brain. At the same time, fat stimulates the release of hormones such as cholecystokinin, or CCK, which is involved in signaling fullness after a meal. Human studies suggest this response may contribute to longer-lasting satiety, although its effects vary depending on the meal and the individual. Imagine placing another log on a fireplace. Rather than creating a quick burst of heat, it keeps the fire burning steadily. Meals that naturally combine protein and healthy fats, such as eggs, salmon, or full-fat yogurt, may provide a stronger and more lasting feeling of fullness than meals built around refined carbohydrates alone. Yet even this partnership has limits, and understanding those limits is where the science becomes even more interesting. If protein and fat help signal fullness, where do carbohydrates fit into the picture? The answer is more complex than many people expect. Carbohydrates provide energy, but according to the source material, they are not the primary nutrients responsible for triggering long-lasting satiety. Foods rich in refined carbohydrates are digested quickly, allowing blood sugar and insulin to rise rapidly before falling again. For many people, this cycle may cause hunger to return sooner, even after eating a meal that seemed filling at first. Human studies suggest that this response varies depending on the type of carbohydrate, fiber content, and overall meal composition, so not every carbohydrate-rich food has the same effect. Imagine burning a sheet of paper instead of a log in a fireplace. The flame appears quickly, but it fades just as fast. By contrast, meals that include adequate protein and healthy fats often provide steadier satisfaction. This doesn't mean carbohydrates should always be avoided, but understanding how different foods influence hunger may help you build meals that are easier to sustain over time. How much protein does your body actually need? The answer may be more than simply meeting the minimum daily recommendation. Minimum intake is generally designed to prevent deficiency, but that doesn't always mean it is enough to support optimal muscle maintenance, tissue repair, or lasting fullness. According to the source material, many adults, especially older individuals and those who exercise regularly, may benefit from a higher protein intake, often ranging from about 1.2 to 2.2 grams per kilogram of body weight, depending on personal needs and health status. Current human research suggests that higher protein diets may help preserve lean muscle during weight loss and improve satiety, although the ideal amount varies from person to person. Think of protein like the maintenance crew for a busy city. A small team may keep essential services running, but a larger workload requires more workers to repair roads, replace damaged structures, and keep everything functioning smoothly. The goal is not to eat as much protein as possible, but to consume enough to match your body's demands. The next question is just as important. Does the timing of protein intake matter as much as the total amount? What actually tells your muscles it's time to grow and repair? The answer may begin with a single amino acid called leucine. Found naturally in high-quality protein foods, leucine acts like a key that helps activate a cellular pathway known as mTOR, which plays an important role in muscle protein synthesis and recovery. According to the source material, a meal containing about 25 to 30 grams of quality protein may provide enough leucine to strongly stimulate this process. Beyond that point, eating substantially more protein in the same meal may not produce a much greater mTOR response, although individual protein needs still vary. Human research generally supports the importance of reaching this threshold, particularly for older adults and people engaged in resistance training. Imagine pressing a light switch. Once the light is fully on, pushing the switch harder doesn't make the room brighter. In a similar way, reaching an effective protein threshold may be more important than simply eating as much protein as possible. But one question remains. Does eating all your protein in a single meal make the best use of this biological switch? Does eating twice as much protein automatically build twice as much muscle? It sounds logical, but according to the source material, the body has practical limits. After a meal, only a certain amount of protein can be efficiently directed toward muscle repair and other essential functions. For many people, this may fall within a range of roughly 40 to 70 grams, although individual needs depend on body size, age, and physical activity. Once that capacity is exceeded, some of the remaining amino acids may be converted into glucose through a natural process called gluconeogenesis, rather than continuing to support muscle building. This doesn't mean extra protein is harmful, but it may not deliver additional muscle building benefits in the same meal. Think of pouring water into a sponge. Once the sponge is saturated, the excess simply runs off instead of being absorbed. Current research suggests that spreading protein across meals may improve its overall utilization, though the ideal pattern still varies among individuals. This naturally leads to another question. If total protein matters, could meal timing be just as important as the amount you eat? If the amount of protein matters, could the number of meals matter as well? According to the source material, meal frequency may influence both muscle maintenance and metabolic health. Eating 3 protein-containing meals each day may stimulate the mTOR pathway multiple times, creating repeated opportunities for muscle protein synthesis. At the other extreme, eating only 1 meal extends the fasting window, which may support certain metabolic goals, but it also provides just one major opportunity to activate muscle-building pathways. If a very large amount of protein is consumed at once, some of it may be redirected through gluconeogenesis instead of supporting additional muscle repair. The source presents 2 meals per day as a practical middle ground, offering repeated protein intake while still allowing a meaningful fasting period. Imagine charging your phone.
Several well-timed charging sessions often keep the battery more stable than waiting until it is almost empty and plugging it in only once. The ideal meal pattern ultimately depends on your priorities, health status, activity level, and long-term goals rather than following a single approach for everyone. After exploring how protein and meal timing influence hunger, one final question remains. Where should that protein come from? According to the source material, whole foods that naturally combine high-quality protein with healthy fats may provide the greatest support for lasting satiety. Foods such as eggs, beef, fatty fish, and full-fat dairy deliver both nutrients together, allowing the body's natural fullness signals to work in partnership. The source also recommends including leafy green and non-starchy vegetables, then eating protein and fat before carbohydrate-rich foods. This sequence may slow digestion and help moderate the rise in blood sugar after a meal, although individual responses can vary. Imagine building a campfire. Large, solid logs burn longer and more steadily than a pile of dry paper that flares up quickly before disappearing. In much the same way, meals built around whole, minimally processed foods may provide more stable energy and longer-lasting satisfaction than meals centered on refined carbohydrates. The goal is not to eliminate every carbohydrate, but to build each meal on a stronger nutritional foundation that your body can use more effectively over time. So where does this journey leave us? Perhaps the biggest lesson is that sustainable weight management is about more than reducing calories.
According to the source material, lasting success begins with understanding the signals your body naturally responds to. Providing enough high-quality protein, pairing it with healthy fats, choosing minimally processed foods, and distributing protein wisely throughout the day may help support fullness, preserve lean muscle, and promote healthier eating habits over time. These strategies are supported to varying degrees by current nutrition research, but individual responses depend on age, activity level, medical conditions, and the overall quality of the diet. No single food or nutrient can guarantee weight loss or perfect health. Instead, think of your body as an orchestra rather than a single instrument. Protein, fat, carbohydrates, movement, sleep, and stress management all play different roles, and lasting health depends on how well they work together. Rather than chasing the lowest calorie number, learn to recognize and respect your body's natural hunger and fullness signals. That simple shift may become one of the most sustainable changes you ever make.